person, I should first remind you about what we looked at last time. We looked at different properties or different angle properties of circles. And I want you to remember very well that all the things that we covered previously, including the things that describe circles, for example, the line, which is called the chord, the segments, the sector, and also your past knowledge about the geometry and about angles should be used in this topic. So get to know what do we call an alternating angle, get to know what do we call vertically opposite angles, get to know what do we call corresponding angles. All those properties are used in this kind of topic, circle properties, angles, circle properties. So last time we looked at different properties. I remember we started from here, and this was the property that we looked at. And this property, what was it telling you? It was just telling you that the opposite angles of a cyclodilateral. A cyclodilateral is a four-sided figure that is drawn inside a circle. So the two opposite angles are going to be equal. So A is equal to C, and also, sorry, A plus C is equal to 180 degrees, and also B plus D equals to 180 degrees. So what we should know is that these angles add up to 180 degrees. B and D, if added together, they add up to 180 degrees. And also A and C, if added together, add up to 180 degrees. Then the other thing is that the two angles A and E are equal. So one exterior angle is equal to one opposite interior angle. So A is equal to E. A is equal to E. Then the other property that we looked at was the one about the alternating segments. And we said that any angle which is in the alternate segment is equal to the angle in the other segment. So the angle which may be in this alternate segment is equal to the angle in this other segment. And the angle in this other segment is X. So X will be equal to any angle that will be found inside this segment here. And also Y will be equal to any angle that will be found in this Y, in this segment, which is here. In other words, the shaded part of this circle is what we call the alternating segment. And this alternate segment is the segment, or it is alternating to the angle Y. It's alternating to the angle Y. So the angle that is found, that is touching the arc, not this one here, this one cannot be equal to Y, but any angle that is touching the arc, as we saw, is equal. So this is what they are talking about. So if this is the chord AB, so the angle D is equal to the angle Y, because AB creates two segments, this segment here and this other segment here. So the angle which is in this segment Y is equal to the angle D, and you can see D is touching the arc in this other segment here. So it means that Y is equal to D, because D is the angle which is in the alternating segment. The same thing with this picture, which is here. X is equal to C, because C is in the alternate segment of X. Okay, so those two angles are equal. Then the other property that we looked at, we said that the angle between a tangent and the radius drawn to a point of contact is 90 degrees. So you can see very well here. Zoom in there very well for you to see. So if this is the tangent, what is a tangent? A tangent is a straight line that is drawn and it's touching the arc of the circle, or it is touching a point of the arc of the circle, a point of the circumference of a circle. And this is a straight line. So if there is a line that is drawn from the center of the circle and touches that tangent, these two lines are perpendicular to each other. The radius and the tangent are perpendicular to each other, meaning that they meet at 90 degrees. So a tangent touching the arc of a circle, tangent touching the arc of a circle, it means that a radius drawn to that point where the tangent touches the arc of a circle, that radius meets the tangent at 90 degrees. And I want you to follow very well how the angles are being written from these letters. So they are saying that CBO is equal to 90 degrees. So you can read CBO. So the letter that is in between, that's the angle that they are talking about. So I'm going through this very fast because remember, this is what we covered the last time. Then we ended with this property, which is here. And zoom out a bit. And they are saying that from any point, okay, zoom in a bit. So they're saying that from any point outside a circle, just two tangents to the circle may be drawn and they are equal in length. So if two tangents are drawn from one point outside the circle, it means that those two tangents are equal in length if all of them come from the same point. So point T is the point the point that is common to the first tangent TA and the second tangent TB. So point T is shared by those two straight lines, and these straight lines become tangents if they touch the arc of the circle from the outside. So at point A, that's where the first tangent meets the circle, and point B, that's where the second tangent meets the circle. So if these two lines are drawn from the same point T, the lines TA and TB are equal. What do we mean? If you measure from T to A and also measure from T to B, those distances are equal. This one you don't need to say, let me use a protractor or do what. You can do it physically. You can do it right now, and then you draw a circle, and then you put a line, a point somewhere away from the circle, and you draw two lines, and those two lines are touching the arc of that circle. Those two lines will be equal in length. They will be equal in length. So that is the seventh property that you should know. Then the other property that we are going to look at today is the property about the intersecting chords. The property about the intersecting chords. What do they mean by the term intersecting chords? We have already seen what chord means. If we have new people in this lesson, I'm seeing Epidu. Epidu, good afternoon.
Good afternoon, teacher.
I'm seeing this is your first lesson, but you should follow up the videos of these lessons that you recorded so that you follow the lesson very well. Otherwise,
all right,
we are happy to have you on board. So the chord, a chord is just a line that is drawn within the circle. It is a straight line that is drawn within the circle. A chord does not pass through the center. A chord does not pass through the center. A chord just passes anywhere. It can be drawn from anywhere. So just for people to understand what a chord is, so if you have a circle that is drawn there like that, you can have a chord running from one point inside the circle to another point outside the circle. So we can have a line that is drawn from this point, so from this point to that point. So this is AB. So it means that AB is a chord. AB is not a diameter. So that is a chord. And if we have two intersecting chords, now for instance, if you have another line drawn within the circle, then these are two intersecting chords, and the other intersecting chord is C what? Is CD. These two chords meet at a point, and this point is not at the center of the circle. It is a point anywhere inside that circle. So what are they saying about these intersecting chords? If we follow our notes clearly and very slowly, we shall understand this. So they are saying that in figure 1, the chords AB and CD intersect internally. So they are meeting inside. That's why they say internally. They are intersecting internally at point P inside the circle. Chords AB and CD meet at point P. So there are two triangles which are formed. There is this triangle APD, and there is also another triangle CPB. Those are two triangles which are formed. So they are saying that those two triangles are similar. Those two triangles are similar. You should also know that CB is also a chord, and also AD is also a chord, because we have said that a chord is just any straight line that is drawn inside that circle, and this line does not touch the, does not pass through the center. So AD is a chord, and also CB is also a chord. But you should know the chords, the main chords that are intersecting are AB and CD, meeting internally at point P. They form two triangles, triangle APD and triangle CPB. Those two triangles are similar. Those two triangles are similar. What do they mean by triangles being similar? A triangle is similar to another triangle if they have equal angles. I repeat, triangles are similar to one another if they have equal and the same angles. Same and equal angles. What do they mean by this? They are meaning that the angle which is here is equal to this angle, and also the angle which is here is equal to this angle. The angle which is here is equal to this angle. So triangles are similar if they have the same and equal angles. That's what they mean. So let me draw here and finish that diagram there. Members, have you understood what we mean by triangles being similar? Yes?
Yes, teacher.
Yes. I can elaborate more if you have doubt. But what you should know is that if any triangle is similar to another, you can have a small triangle. You looked at similarity. You can have a small triangle, and you can have a bigger triangle. These triangles are similar because they have the same angles. The angles are the same. That's what we call similarity. If you remember very well when you're still at school, that's what you looked at when you're looking at similarity. Angles being the same, the size may be different. The size may be different, but the angles are the same and are equal to one another. So triangle CPB and triangle APD are similar. If they are similar, then they have helped you and they have summarized and they have said that if those triangles are similar, they have said that angle. Maybe what we should know is that we should first write what the law is, or what this property is. So the property, this property, I want you to understand it very well, and then you get to know how it is written. So the angle C is equal to the angle A, and the angle B is equal to the angle D. Are we together? And they are saying that angles in the same segment. Angles in the same segment. Angle C is equal to the angle what? Is equal to the angle A. What do they mean by that? That angle C is equal to the angle A, and they are saying that angles in the same segment. They would have said that angles are similar because the triangles are similar, but also this one applies. It is also correct because angles are in the same segment. Suppose if you want to see that, if we draw a dotted line here like that, you will see that. Let me show you. If we draw a dotted line here from B to D, you see that this line will create two segments, this segment and this segment. So it means that the angle which is here shall be equal to this angle. That's what they are saying. So angle C, so what you should know is that first of all, you should write triangle APD and triangle CPB are similar. Similar. What? Are similar. You can leave this one, this was side work. Are similar. Then you can say that angle, so we shall say angle C, okay, is equal to the angle A, and also you should know that angle B equals to the angle D. So angle B is equal to the angle D. So, and I've said that angles in the same segment. Angles in the same segment. So angle B is equal to angle D. That's what they have said now. This angle, which is here, how have they called this angle? This angle is APD. So APD is equal to the angle CPB. I think you can see this. So that's why they have said that angle, also what you have to know is that angle CPB, the letter in the middle is the angle we are talking about, CPB. So between this line CP and PD, that's why they say CP and PB. So the angle is between, the angle is here. So the angle between CP and PB. So that angle which is there, I know some of you want to zoom. So that angle, or the angle P, is equal to the angle, is equal to which angle, members? A what? APD.
APD.
And those angles are equal, and we call these ones vertically opposite what? Vertically opposite angles. Vertically opposite angles. That's the property that makes them to be equal to one another. That's the property. Now, what you should know is that if these triangles are similar, then CP over AP is equal to PB over PD. What are they saying here? They are saying that if you get this side, let me just zoom in there. I know the teacher wants to zoom in. Yeah, correct. So if you get this side, CP, and you divide it by this other side of AP, that ratio, you know what ratio is? Ratio means division. If you get CP divided by AP, that ratio is equal to PB over what? PD, because that's what we looked at under similarity. Under similarity. So under similarity, if you get the length of the big over the length of the small is equal to the other length of the big over the length of the what? Of the small. Even you can even say CB over AD is equal to CP over AP. So you should know that if you get the length of the other one and divide it by the similar length of the other triangle. So this is the length of the first one, and this is the similar length of the other one, because these two lines meet at this same point here. It may not be the reason, but you should know that this line is similar to this. This line is similar to this. So CP over AP is equal to PB over PD. So those ratios are equal, and that's what we are going to use. And we shall say that CP over AP shall be equal to PB over PD. So you can see that CP is for this, and also PD is for this. In other words, when you start with this, you say CP over AP is equal to PB over PD. You don't say is equal to PD over PB. No, it should be this one first over this is equal to this one first over this. Are we together?
Hello.
Are we together?
Yes.
So even that one here, they have put it even in what? They have tried to put it in what? In brackets. Though they are saying it is not part of what we want to know, but you know that under similarity, that also this length of this CB over AD is also equal to this, is also equal to this. So this over this, the first one over this is equal to this first one over this, which is also equal to this length CB of the first one over this of the second, like that. Suppose this is the first triangle and this is the second triangle. So the first length CP over the second length of this is equal to this of the first over this of the second, which is also equal to this of the first over this of the second. That's what they mean. So from here, in case we are told to find the length of this triangle, so here you just cross multiply and you have AP times PB is equal to CP times PD. That's what we looked at when you're looking at similarity. Remember very well when you're looking at with similarity. So that's what they looked at. So you can use also that property in case they ask you find the length CP, find the what. If these other lengths are given, you can find the length using this kind of similarity that we have there. Okay. So let us look at the second diagram here. In the second diagram. So in that second diagram, they are saying similarly in figure 2, chords AB. I'm saying chord AB, A to B, full stop. It is not AP. AP is not a chord, but the chord is AB. Similarly, chords AB and CD intersect externally at point P. So if chord AB is extended, and also chord CD is extended, they will meet somewhere at point what? At point P. Why? Because chord AB and CD are not parallel. Let me ask members, do you know parallel lines? Maya, do you know parallel lines? Maya, do you know parallel lines? Parallel lines? Who knows what parallel lines are?
Lines that don't
Okay. Sherry, good.
Meet. There are lines
They are what?
that meet. Lines that don't meet.
Lines that do not meet. They are parallel. If someone says we are parallel, it means you don't meet, you don't agree on some issues. You don't agree on, you don't have anything in common. So at any one point, you never agree. So we are parallel. So even if lines are parallel, they don't meet. But these lines are not parallel. CD and AB are not parallel. They meet at a common point if extended. If code AB is extended, it meets at point B. So that's what they are saying there. All right. So similarly, what you should know is that codes AB and CD intersect external at point P. Therefore, the triangle, now we have here triangles. We have triangle CPB, CBP, or CPB, and also triangle ADP or APD. This triangle here, and also this triangle here. Those triangles are also similar. They are similar. So you should also draw that in your books, and draw that, members, draw that. You should have that also. So they have drawn. Let me put this one here. Okay, so they have drawn. So if something is drawn like this is the second diagram. Should use a compass, which I don't have, but I'm going to get it. You wait. So if these chords, the first chord is CD, so it is extended to point this, and there is another chord there. So this is point P, and this is point A, this is B, this is C, and this is D. So those are the chords. Sorry, these are the lines. But the chords, the first chord is, the first chord was AD. That is chord AD. And then the other chord is C. I beg your pardon. So we have chords AB. Sorry, the chord is AB and the other chord is CD. Those chords, if extended, meet at point P. Now they form these triangles. Let me first emphasize this triangle here. We have this triangle here. You can see that triangle, which I've emphasized this one. This triangle here. So triangle. So we can write there and say triangle. We shall say triangle APD, APD, and triangle, this triangle CPB or CPB, CPB are similar. They are similar. They are similar. Now, if they are similar, it means that this angle which is here is equal to that angle. And also this angle is equal to this angle. This angle which is here is equal to this angle. And also this angle which is here is equal to this angle. That's what we mean by similarity. So all these angles are going to be equal because the triangles are similar. They are similar. Are we together? Okay. Yes. So that's why they are saying that angle. So you can say angle C is equal to the angle what? A. That's first thing. And also we can say angle B equals to angle D. That they're all similar. But you can see also these angles C and A, they are similar because they're in the same segment. Suppose we draw a line here. Eh? This will be in the same segment. Something like that. Okay, so that's what you have to know. This is very important. That's where the law is. That is very important. And also this one here that we looked at, this is where the law is. That's where you have to know the law, that those angles are equal because the triangles which are formed, are similar. Then the other part where they tell you CP, for example, they are saying CP over CP over AP is equal to PB over PD. It is okay. There they are just using the knowledge of similarity of triangles. That if you get this AD, sorry, if you get AP, the bigger AP of this side over CP of the other side is equal to the smaller one, PB over DP. They are using the property of similarity, full stop. That's what they are using. But they are also telling you it is also, they're also telling you that also this one is equal to CB over a what? AD.
Excuse me, teacher.
Yes.
Could you please repeat that?
This.
Yeah.
So what they are saying here, you look at this AP, if you are looking at this triangle, let me shade this one, to differentiate the other one. So if they are saying AP, so you get the length of the first triangle AP over the length of the other triangle. Now the other triangle is this one, CBP. Are you seeing that? CBP. So the length of this triangle here over the other side of the are you getting it? Yeah. So now if this is the triangle, this is like the base, isn't it? This one.
Yeah.
And this one is inverted. So its base is this one. So the base of the first triangle over the base of the other triangle is equal to the distance from here, apart of the base, BP over DP. So the first triangle. So you shouldn't say AP over CB. That would be wrong, isn't it? Because this one is not a base of the second triangle. You understand? So if you have started using bases, then you say AP over CP. You get it?
Yes.
That is it. So it is equal to, so it can be also be equal to PB over DP, because this is the length, this is part of the base of the first triangle over this part of the base of the second triangle, which is also equal to AD. I can say AD over CB. That is also correct. Are we together?
Yes.
In fact, this one shouldn't be CB. This one should be AD over CB. Because CB is on the second triangle and AD is on the first triangle. So we said the first triangle over the second triangle. Yes, that's why we have AD over CB. Not the way it appears here. Okay. So we have something like 1 minute. So when we come back, we are going to look at the example to that. But let me show you this example so that you can first figure out what the answer is. So that was number 7, and let us look at example. This example, which is okay. It's complicated. Don't say that. We looked at this and we found out the answer. So I think afterwards we have looked at all these examples. So what we are going to do, we are going to to go straight to the exercise, and we are going to do some questions, and that should be the end of of angle properties. So tune in back after this break of 2 minutes.